What if the reason the universe has no edges feels like a rule is simply because the expansion story makes edges inconvenient? In the energy filament theory, the cosmos can be a finite energy sea with a real physical boundary. And no center does not automatically mean no boundaries. The mainstream narrative usually runs like this. Galaxies are receding, space is like a balloon being inflated. And from any galaxy the redshift pattern looks similar, so there is no special central point. Then a second idea gets stacked on top: we are not special. And the conclusion quietly slides in: if every direction looks roughly the same, stop talking about an overall edge. The word boundary gets treated like a philosophical mistake. That sounds tidy, but an everywhere expanding, possibly infinite universe carries its own unpaid bills. First is the energy book. If the universe is roughly uniform and truly infinite, the total energy is also infinite. And many everything-day sounding questions became weirdly dependent on mathematical limits doing the heavy lifting. Second is the dynamics book. If the entire stage is doing a global getting bigger motion, what is the engine? The common answer is dark energy, a hidden component that pays for accelerated expansion. In plain language, it often feels like adding a new charge to cover a missing term in the equation, not discovering the physical motor that must exist. Third is the extrapolation habit. We only observe a finite patch, the observable universe. Yet we often promote this region looks close to isotropic into the whole thing is infinite and everywhere the same. That promotion is a choice. It is not forced by the data. And there is an even stranger leaping hiding under the hood. Standard cosmology often starts with a Big Bang singularity, a point-like beginning with infinite density. Then in a short story told by equations, the universe becomes something that can be treated as spatially infinite. That is a jump from mathematical zero to mathematical infinity. It may be a workable modeling language, but it should never be confused with a concrete physical process you can picture. So ask the real questions. Are we humbly using mathematics to describe what the universe does, or are we picking a geometric picture first and then insisting the universe cooperate? This episode is not a verdict that an infinite universe must be wrong. The point is narrower. The universe must be boundless is not a law of observation. It is a default conclusion that becomes comfortable once you adopt expansion, less the slogan "we are not special." It also conveniently deletes a whole class of hard questions. How would an edge move? Would it reflect? Would the region near it look different? And would that create observable signatures? The easiest way to avoid edge physics is to assume there is no edge. In this picture, we run the logic in reverse. Start by allowing the cosmos to be a finite amount of energy in an energy sea, and let an edge exist. Then give the edge a specific physical character, not a mystical wall. You can picture it like a shoreline where the relay of interactions breaks down. The sea becomes so loose that the propagation chain fails. So forces can jitter locally but cannot carry influence outward. It is a forced desert, not a reflective boundary that would obviously bounce signals back. Once the edge is a physical threshold rather than a mirror, the usual objections change shape. The "you are making a center" objection weakens. The CMB must be uniform so edges are impossible objection becomes a testable claim instead of a veto. And energy bookkeeping becomes clearer. Because finite energy in a finite responsive region is a concrete physical statement, not an infinity handled by limits. Next, we'll get specific. If a boundary is real, what should it do to light, to background radiation, and to structures near the rim? And why would those effects not automatically make us special? Tap follow, share it on New Physics, Clear Universe.